Hello, welcome back to state differential equation. So in this section, we'll talk about separable differential equation. So an equation that can be written in the form gy times y prime of t is equal to ht is said to be separable. The factor gy involves only y and ht involves only t. In general, we solve a separable differential equation by integrating both sides of the equation with respect to t. Like you can see, if we have the integral of gy times y prime of t dt is equal to h of t dt, integral of h of t dt. So we can use, basically, if we have this, we can use, give me 1 second. So I was looking for my pen. So, if we do substitution, you can see this is like my dy. Okay. And then we can integrate this one easily. So now, let's jump and do the first example. You can see we are asked to find a function that satisfies the following initial value problem. We have what? Y prime of t is equal to y squared e to the power of negative t. And the initial solution is y0 is equal to 1/2. So let's go. So the equation is written in separable form, right? This is in separable form. Yt is equal to y squared e to the power of negative t. So if we divide both sides by y squared, both sides of the equation of by y squared, we will have what? Y prime of t divided by y squared is equal to e to the power of negative t. So now we now integrate both sides with respect to t. Now integrate both sides with respect to t, which means we will have the integral of 1 divided by y squared, y prime of t dt would be equal to the integral of e to the power of t dt. Or my y prime t dt is what? dy, right? So this means the integral of dy over y squared is equal to the integral of e to the power of negative t dt. So we know the entire derivative of this dy over y squared is negative 1 divided by y would be equal to the entire derivative of e to the power of negative t is negative e to the power of negative t plus c. So solving for, we are going to solve this one for y. Solving for y gives what? Yt would be equal to 1 divided by e to the power of negative t plus minus c, sorry. Let me solve for y so you can see. Because by looking at it, we can solve. So basically, if this is -1 divided by y is equal to -e to the power of -t plus c, so that means y would be equal to 1 divided by e to the power of -t minus c. So that's just like my new function yt. So we will write yt is equal to 1 divided by, because this is negative, so you multiply both sides by negative, so you will have e to the power of -t minus c, and since it's 1 divided by y, so the reciprocal, that's what I did, okay? Right? Or we know we have the initial condition. The initial condition is y0 is equal to 1/2, which means finding y0 here, y0 would be what? 1 divided by e to the power of -0 minus c. So e to the power of 0 is 1. So 1/2 would be equal to 1 divided by 1 minus c, right? So we multiply both sides by 1 minus c and 2. So you do cross multiplication. So this means 1 minus c would be equal to 2, right? So which means c would be equal to -1. So since c is -1, we obtain the solution to the initial problem will be yt will be equal to 1 divided by e to the power of -t plus c, plus 1, sorry, plus 1. So c is -1, negative and negative will be positive. And this will be my solution. Okay. So same thing. Example, we are asked to find the solution of the equation y prime of x is equal to e to the power of -y times sinus x, subject to the three initial conditions. Y0 is equal to 1, y of pi over 2 is equal to 1/2, and y of pi is equal to ln of 2. So again, solution. Let's find the general solution first, okay? We have y prime of x is equal to e to the power of -y sinus x, right? So again, I have to move the e to the power of -y to the other side, right? So again, by dividing both sides by e to the power of -y, or multiply both sides by e to the power of y, this will cancel, right? So again, by multiply, I'm gonna multiply so it will be canceled easily. Multiply both sides by e to the power of y. So we'll have e to the power of y times y prime of x will be equal to sin x. So integrate both sides now. Both sides of the equation, that will give us the integral of e to the power of y times y prime of x dx will be equal to the integral of sin x dx. So this is dy, so this is e to the power of y dy is equal to the integral of sin x dx, right? The integral of e to the power of y dy is equal to the integral of sin x dx. So which means e to the power of y will be equal to negative cosine x plus c. So we have to solve for y. Solve for y, right? So we will apply ln on both sides. So yx will be equal to ln of c minus cosine of x. So now, again, this is what? This is the general solution to the problem. Now we have to use the three initial conditions. The first condition is what? So initial condition, the initial condition. So if y0 is equal to 1, this imply 1 will be equal to what? Because y0 is equal to 1. 1 will be equal to ln of, ln of c minus cosine of 0. Cosine of 0 is 1. So this means 1 will be equal to ln of c minus 1, right? And then we apply exponential on both sides. So we'll have e will be equal to c minus 1. So which means c will be equal to e plus 1. So in that case, my initial solution will be yx would be equal to ln of e plus 1 minus cosine of x, right? For the initial condition 2, which is y of pi over 2 is equal to 1/2. This means y of pi over 2 is equal to 1/2. This means 1/2 is equal to ln of c minus cosine of pi over 2, right? And what is cosine of pi over 2? That is 0. So this means 1/2 is equal to ln of c, which means c will be equal to e to the power of 1/2. So in that case, my yx will be ln of e to the power of 1/2 minus cosine of x. Right? And last, not the least, 3. The third condition is what? Y of pi is equal to ln of 2. So this means ln of 2 is equal to ln of c. Ln of c minus cosine of pi. And cosine of pi is what? 1. So ln of 2 will be equal to ln of c plus 1. Cosine of pi is -1, so ln of c plus 1, which will give me what? Ln and ln will cancel out. So this means 2 will be equal to c plus 1, which means c will be equal to 1. So in that case, my initial solution will be yx is equal to ln of 1 minus cosine of x, and that's it. Right? Let's do the last problem for this section. Find the solution of the initial value problem, cosine of y times y prime of t is equal to sine square of t times cosine of t when y0 is equal to pi over 6. So again, solution. So in this case, we will integrate both sides again. We have the integral of cosine of y times y prime of t dt will be equal to the integral of sine square t cosine of t dt. So which is the integral of cosine of y dy should be equal to the integral of sine square t cosine of t dt. So we integrate both sides. So we'll have the integral of cosine of y is sine y. And this one is 1/3 sine cube of t plus c. So we have y0 is equal to pi over 6, right? So for this example, we can see to integrate, we'll integrate both sides, right? We'll have cosine of y dy is equal to the integral of sine squared cosine t dt. So the integral of cosine of y is what? Sine of y. Sorry, I think I skipped something, so we have to start everything. And the antiderivative of sine squared t cosine t is 1/3 sine to the power of 3 t plus c. So you can see this is the general solution, right? This is the general solution. So now to find the initial solution, we know the initial solution said what? Y0 is equal to pi over 6. So this means t is equal to 0 and y is equal to pi over 6. So if I substitute them, I will have sine of pi over 6 should be equal to 1/3 sine cube of 0 plus c. And sine of pi over 6 is 1/2. Sine of 0 is 0. Sine cube of 0 will be 0. 0 times 1/3 will be 0 plus c. So this means my c is what? 1/2. So that means the solution of the initial problem, value problem, is sine of y is equal to 1/3 sine cube of t plus 1/2. And that's it. We'll see in the next section. Okay.